Today we're going to be talking about in behavior, how to find it and how to write in behavior in interval notation. So go ahead and add that to your table of contents and then we will get started. I'll give you the answer key to the quadratics homework tomorrow, as well as the answers to this homework. When we talk about in behavior of polynomials, it might be helpful just to first know what a polynomial is. A polynomial means there's going to be many terms. Oops, sorry. Many terms, because poly means many. When we talk about in behavior, we're talking about what is happening on the ends of the graph, so on the left side and the right side of the graph, and we'll get more into that, but we have to know what affects it. So there's two things that affect the in behavior of a polynomial. The first thing is the degree. The degree of a polynomial is determined by the highest exponent. It is determined by the highest exponent. Throughout this lesson and as we go further into this unit, the variable that we give for degree when we're talking about it is the variable n. I know that's kind of weird because there's no n in the word degree, but when we talk about n, that's what we're talking about. We're also going to use the sign of the leading coefficient. That will also affect the end behavior, but you got to know what a leading coefficient is in order to find it. It is the number in front of the variable with the highest exponent. It's the number in front of the variable with the highest exponent. The variable we give for this is a. So if we talk about n and a later on, n refers to the degree, a refers to the leading coefficient, or at least the sign of it. So when we're given a polynomial, we can either be given a polynomial in standard form or in factored form. When we go through these next examples, we're going to find the degree and the sign of the leading coefficient, and the first two are going to be in standard form. Standard form, you know it's in standard form if there's no parentheses, if all the factors have been multiplied. It's very easy to find the degree of a polynomial in standard form. When a polynomial is in standard form, look at the highest exponent of x to find the degree. So let's walk through each of these. The degree of this first one, or the n value, we just simply find the x with the highest exponent, and that's this x to the fourth right here. The degree would be 4 because the highest exponent on that x is 4. The sign of the leading coefficient, our a value, we just simply look in front of that x to the fourth and we see a positive there, or we don't see a negative, so it's assumed that it's positive, so our a in this case would be positive. On example B, to find the degree, we find the highest exponent that x ever has, and that is right here. If we don't see an exponent, we assume we know that it's 1. And to find the sign of the leading coefficient, our a value, we look right out in front of it, and again, it is positive. So both of those are in standard form. Find the highest exponent, that's your degree. Look at the sign out in front of that value and tell me whether it's positive or negative. When a polynomial is in factored form, we have to do a little bit more work to find the degree. When a polynomial is in factored form, multiply the exponent on each x. Multiply the exponent on each x with the power that it's raised to. Then add the x's exponents together to find the degree. So when a polynomial is in factored form, you know it's in factored form because it'll be broken up with parentheses and different binomials. You're going to take a look at each factor and determine the degree on each of those factors. So this one, our x raised to the first power, so I'm just going to put a 1 down here. This one, our x is raised to the first power, and this whole factor is just raised to the first power. So 1 times 1 is just 1. So this is a degree of 1. And the next one, this x to the second is being raised to the fourth power. So we're going to take 2 and multiply it with 4. 2 times 4 is 8. So that factor has a degree of 8. Then you're going to take each of those and add them together. So 1 plus 1 plus 8 gives us a degree of 10. So what that's telling us is that eventually, if we multiply all this together, which we're not going to do, but if we had to multiply all of those factors together, your highest power on x, you'd eventually land with an x to the 10th. Our a value, when it's in factored form, you simply look all the way out in front. So look out in front here, and we'll notice that it's positive out there, so our a value, our leading coefficient, is going to be positive. Let's try it again, and first find the degree, which again, we use the variable n to talk about it. This guy doesn't have an x at all, so we're not going to add anything there. This one is x to the first. It's being raised to the first power, so that factor has a degree of 1. The next one, we have x to the first, but it's going to be raised to the second, so that x will eventually change to x squared. And the last one, we have an x to the first, and x minus 5 has an exponent of 1. Multiply those together, and we get 1. Once we find the degree of each of the individual x's, we're going to add them together. 1 plus 2 plus 1 gives us a degree of 4. So eventually, if we were going to multiply all those factors together, your highest value of x would be x to the 4th. So our degree is 4. Our a value, or our sign of a, look out in front here, and we see that that leading coefficient is, or the leading term is positive. So our x to the 4th, if we were going to multiply this all out together, would also end up being positive. The degree and the sign of your leading coefficient are all going to affect your end behavior. End behavior describes both the left and right behavior as x approaches positive infinity and negative infinity. It is affected by the degree and the sign of your leading coefficient. Sign of your leading coefficient, or the sign of a. Remember that n refers to the degree and a refers to the leading coefficient. So there's 4 different scenarios that will occur with end behavior, and we're going to break them down in the next part of the notes. In this first scenario, all the degrees are going to be even, and our a value, our leading coefficient, is going to be positive. So our degree is going to be an even number, and our a value is going to be positive. So instead of just telling you what's going to happen, I want you to think about the graph y equals x squared. In y equals x squared, your degree is 2. That is an even number. Your a out in front, your leading coefficient, is positive. Y'all know what y equals x squared looks like. It's your basic parabola. Your end behavior, what we're thinking about here, is what is happening on the left-hand side and what is happening on the right-hand side. Another one that we could look at is y equals negative x to the 4th. I'm sorry, why did I write negative? Y equals x to the 4th. Y'all probably don't know what that looks like, but in general, it looks fairly similar to a parabola. Sometimes it'll end up looking like a W, but if you just graph y equals x to the 4th in your calculator, it's going to look very similar. We have an even degree. We have an a that's positive. On the left side, it's going to the left. On the right side, it's going to, on the left side, it's going up, and on the right side, it's going up as well. So when n is even and a is positive, we don't care about all the stuff that's happening in the middle, but in terms of your end behavior, on the left side, it's going to go up, and on the right side, it's going to go up. So even positive goes up on both sides. Now we're going to introduce how we describe this end behavior with limit notation. Limit notation looks confusing at first, but it's like a math sentence in a little bit of a different language. This is saying the limit as x goes towards negative infinity of f of x equals, this is just saying as the x is getting smaller and smaller, the y values are going toward, and you're just going to answer with whether it's going towards positive infinity or negative infinity. As x goes toward negative infinity, we should be looking at the left-hand side of the graph. So as x is going towards negative infinity, what is happening to our y's? Well, they're going up, so they're going towards positive infinity. The second limit that we need to write is the right side of the graph. So what is the end behavior on the right side of the graph? That is as the x is going towards positive infinity. So we're going to look at the right-hand side of the graph here. The limit as x goes towards positive infinity, well, what are the y's doing again? They're going up. So our answer would be positive infinity. With these problems, with these like limits, your answer is either going to be positive infinity or negative infinity. So on both of them, in this case, it's positive infinity because the y values are increasing on both sides. The next thing we're going to look at is when n is still even, but our a value is going to be negative. So our degree is going to be even, but our leading coefficient is going to be negative. So that would be something like negative x squared. We know from yesterday's class and from many years of math experience that that's just going to flip the graph over, reflect it over the x-axis, I should say. Another example going along with that one that we just did is y equals negative x to the fourth. Again, our degree here is even, our a is negative. That's just going to reflect it over the x-axis. So when n is even and a is negative, we don't care what happens in the middle of the graph, but in terms of the end behavior, on the left side it's going down, on the right side of the graph it's going down in both of those scenarios. So if we're going to look at our limits and write it in limit notation, you'll notice that this first part looks exactly the same. That is going to look the same every single time you write the end behavior of a limit. You're just now looking as x goes toward negative infinity on the left-hand side of the graph. What are the y values doing? Well, now they're going down. So our limit as x goes toward negative infinity is negative infinity. As x goes toward positive infinity on the right-hand side of the graph, you'll notice that it's going down as well. So our limit on the back side of our graph, we're going to, on the back side of our notes, we're going to look at when your degree is odd. So go ahead and flip that over. Positive. Oh, goodness. And let's now look at when our degree is an odd number and when a is positive. So this is saying our highest exponent needs to be an odd number, so y equals x cubed, and the coefficient in front needs to be positive. Y equals x cubed is one of those parent functions that we looked at last unit. So y equals x cubed looks something like this. Another one that you are familiar with that is like even simpler than that is y equals x. Y equals x has a degree that's odd, and the leading coefficient out in front is positive. Y equals x is just your basic line that goes through the origin. You'll notice on, like, while the middle of these graphs look different, the end behavior is the same. When n is odd and a is negative, on the left side, the graph is going to go down. On the right side, the graph is going to go up. So let's take that and apply it to limit notation. In limit notation, you'll notice that the limit looks exactly as it did on the previous page, but now we're looking at a different kind of graph. We're looking at when the degree is odd and a is negative. In this case, when x is going towards negative infinity, imagine you're looking at the left-hand side of the graph, the y values are shooting down, so our f of x is going towards negative infinity. As x is going towards positive infinity on the right side of the graph, the y values, or f of x, is going up, so it's going towards positive infinity. So when you have an odd function, your limit's going to go in opposite directions. Let's continue with that, but apply it to when n is still odd, but your a is negative. So this would be like y equals negative x cubed. Reflects it over the x-axis. Or you can think about your basic line y equals negative x. That has an odd degree of 1, and it has a leading coefficient that is negative. That's your line that has a slope of negative 1, goes toward the origin. Same in behavior occurs, even though the middle of the graphs are different. So the n is odd, and our a is negative. On the left side, it's going to go up. On the right side, it's going to go down. So the last limit that we need to talk about, as x goes toward negative infinity, remember that's the left-hand side of the graph. So as x goes towards negative infinity, as the x's are getting smaller, what is happening to our y's right here? They're getting larger, so they're going towards positive infinity. And as our x's are getting bigger, that's the right-hand side of the graph, what are the y's doing? Well, they're shooting down, so that is going towards negative infinity. In these last 4 examples, all we're going to do is describe the end behavior of the graph in limit notation. We are not going to graph it. We're simply going to look at the degree and the sign of a, and then use what we've just talked about in our notes to determine what that end behavior would look like. So example number 1, we know it's in standard form because we don't see any parentheses. So to find the degree, we are going to look at our highest exponent. To find the sign of your leading coefficient, you're going to look at that number out in front and see if it's positive or negative. So in this case, n, the degree is 3, which is an odd number. Our a, the value out in front, is positive. So in this case, we have an odd positive graph. So if you need to, think about your odd positive, like y equals x cubed. I know that this graph is like going to have more going on with it, but if you have y equals x cubed, you're going up on the right side, down on the left side. We're going to take that information and write the limits that go along with it. So we're all going to practice writing our first limits. And if you're wondering why these limits show up constantly in calculus, and we are in pre-cal, so we're learning it now. So we write the limit as x goes towards negative infinity of f of x, and we'll look at the left-hand side of the graph first. Well, as the x's are getting smaller and smaller over here, where are our y's going? They're going down towards negative infinity. So our limit would be negative infinity. Then we're going to write the limit as x goes towards positive infinity of the function. Well, as x gets bigger and bigger, what is happening to our y values? They're getting larger and larger. So the limit would be positive infinity. Again, your answer is either negative infinity or positive infinity. So you have a 50-50 chance of getting it correct. Scoot on over to number 2. In number 2, we're in factored form. So when we find the degree, we have to find the degree of each factor and then add them together. So this obviously has a degree of 2. This one also is going to have a degree of 2. We add them together to get that our n value is 4, which is obviously an even number. To find the sign of a, we look all the way out in front. Is our a value positive or negative? In this case, it is positive. So we don't need to graph the specifics of this one. Just think about an even positive graph that you're comfortable with, like y equals x squared. Degree is even, the a value out in front is positive. So it's like your case of your parabola. We don't know what goes on in the middle. All we're caring about is this end behavior. So we'll write the limit as x goes toward negative infinity of the function, and the limit as x goes toward positive infinity. As x goes toward negative infinity, that's talking about as the x's are getting smaller. These y values are going up, so our limit would be positive infinity. As x is getting bigger, the y values are getting positive as well, so it goes toward positive infinity. Check out example number 3. In example number 3, it's in factored form, so you'll need to find the degree of each of these factors and then add them together. So in the first factor, the degree on x is 3. And the second one, we'll take 2 and multiply it with 3 to get a degree of 6. And then in the last one, x to the first is still raised to the first power, so it's a degree of 1. Add 3 plus 6 plus 1 to get a degree of 10, which is an even number. When it's in factored form, to find your sign or your leading coefficient, you just need to go all the way out in front of the parentheses. And our a value in this case is negative. So we have an even negative here. Think about, I know this polynomial is like wild and crazy and all that stuff's going on, but think about an even negative, like negative x squared, and all we care about is the end behavior of that. It's like a parabola facing down. So we're going to take that end behavior. I would always make that little diagram to help you out with your limits, to talk about the limit as x goes toward negative infinity of the function, and the limit as x goes toward positive infinity. See if you can fill in whether those are going to be positive infinity or negative infinity in this case. On the left-hand side, as x gets smaller and smaller, your y's are also going down, so that's going towards negative infinity. On the right-hand side, as x is getting bigger and bigger, your y's are still going down, so that would also be negative infinity. So both your limits there should be negative infinity. And the final one, this one's a little out of order. It's in standard form because it doesn't have parentheses, but make sure that you're searching for the highest exponent to find the degree and then looking out in front of it to find the degree. So take a moment, fill in what n is and what your leading coefficient sign is. In this one, our degree is going to be 7, which is an odd number, and our a value is going to be negative. So think about a negative odd function like y equals negative x or y equals negative x cubed, and make a little diagram for yourself so that you can figure out what the end behavior is going to be. Again, there's going to be all sorts of complicated stuff that occurs in between here. All we're talking about today is the end behavior, what's happening on the left side of the graph and on the right-hand side of the graph. Once you've made your little diagram, set up your limits. The limit as x goes toward negative infinity, and the limit as x goes toward positive infinity. Go ahead and take a moment and try to fill in whether what the limits are going to be. On the left-hand side of the graph, as x is getting smaller and smaller, these y's are actually getting larger and larger. So your f of x, your y values are going towards infinity. On the right side of the graph, as x is getting bigger and bigger, your y's are getting smaller and smaller, so your limit is approaching negative infinity. I'm going to zoom out, and if you need to get any of those examples down again, you can snag them here. On your homework, you'll just be practicing finding the degree, finding the sign of a, and then using both of those to determine the end behavior and writing your end behavior in limit notation each time. Email me if you have any questions, and I hope you have a good day.